we present our work language-guided image reflection separation. When taking photos of a scene with a camera, we can typically get a clear and clean image. However, if we take photos in front of a piece of glass, the presence of reflections can significantly degrade the image quality of captured images and disrupt downstream computer vision tasks. Reflection separation aims at decomposing the contaminated mixture image into two components, that is, the transmission layer and the reflection layer. However, reflection separation is a severely ill-posed problem, thus it is imperative to exploit effective auxiliary information for distinguishing the two components. Recently, language descriptions have shown their effectiveness in providing content information for vision tasks such as image editing, semantic segmentation, and image colorization, which inspires us to think about, can we leverage the language descriptions to facilitate the reflection separation problem? The answer is affirmative. Language can effectively convey humans' prior knowledge about the real world and can provide auxiliary descriptions of image semantics for transmission and reflection scenes. Therefore, in this work, we exploit the problem of introducing language descriptions to guide the separation of reflection and transmission layers from mixture images. Leveraging language descriptions for reflection separation is non-trivial in three aspects. The first is the language-image modality inconsistency. Language and images belong to different modalities. Thus, it is challenging to establish a cross-modality correspondence between the scene content in language descriptions and the complex blended content in mixture images. The second challenge is the recognizable layer ambiguity. The recognizable extents of reflection and transmission layers in mixture images are uncertain. Specifically, it is possible that either one or two layers exhibit recognizable content, leading to the difficulty of using uncertain quantities of language descriptions. The third challenge is language annotation deficiency. All existing datasets for the reflection separation task only contain image data, but no correlated language description is provided, raising the challenge for network training and evaluation. After the analysis of the challenges of introducing language descriptions, we start to introduce our method. If we have a reflection-contaminated mixture image, we can provide a transmission description and an optional reflection description. For the first feature extraction stage, we get image and language features using pre-trained encoders. Then in the gated language interaction stage, the transmission description and image feature are fed into in cascaded interaction groups for separating clean transmission feature. Each interaction group contains an adaptive global aggregation module to gather global information of input visual features. Then a language gate is employed to prevent detrimental guidance from unavailable descriptions, and an adaptive global interaction module conducts interactions for exploring holistic image-language content correspondence. After getting the clean transmission feature, we obtain the transmission layer with a simple image decoder in the layer recovery stage. We use another and interaction groups for separating reflection feature and obtain the reflection layer with another image decoder. We build a dataset containing both synthetic and real data to overcome the annotation deficiency. We utilize two prevailing image captioning datasets, that is, Flickr 30 and Coco captions for synthetic data generation. We randomly select images with descriptions and conduct linear blending to generate mixture images. For the real data, we manually adding language descriptions for the off-the-shelf real datasets, and further collect a real dataset containing 100 mixture images from the internet for evaluation. We conduct experiments to validate the effectiveness of the proposed method. As shown in the last column of the table, our quantitative results of transmission recovery validates generalization capacity of our method and the effectiveness of language descriptions. Here are the qualitative results. We first show results generated by a state-of-the-art single image reflection removal method. And then we show results from the proposed language-guided method, which better separates the white reflections in this example. In this example, the reflection of a man in a painting in a room is correctly separated by the proposed method. After introducing language descriptions, the proposed method successfully separates reflections of the trash bin and the cabinet. In this example, the proposed method manages to distinguish the reflection of the white door, which validates the efficacy of language descriptions. That's all about our paper. Thank you for listening.